Discussing problems on how to calculate the Riemann sum both ways. So first of all, what does the Riemann sum say? It says that integral a to b fx dx is limit as n tending to infinity, summation k equal to 1 to n f of a plus k delta x into delta x, where delta x is b minus a by n, x naught is a and xn is b. So let's start with a problem on this. Write limit as n tending to infinity, summation k equal to 1 to n (2 plus 5k by n the whole squared into 5 by n as a definite integral. So the solution will be, we have limit as n tending to infinity, summation k equal to 1 to n f of a plus k delta x into delta x is integral a to b fx dx. This is a formula where delta x is b minus a by n. So comparing it with the formula, we can say that a is 2 and delta x will be 5 by n. Now delta x is b minus a by n. So that would mean that 5 by n equal to b minus 2 by n. So the n gets cancelled and comparing it you get b as 7. So this will be integral 2 to 7 x squared dx, because you have 2 plus 5k by n the whole squared. So this is your integral. Now let's work backwards. Coming to the next question, write integral 1 to 4 x squared x cubed minus 2 dx as a Riemann sum. So we have the definite integral and we have to write it as a Riemann sum. So a is 1 here, b is 4 and delta x will be b minus a by n, that is 3 by n, 4 minus 1 by n, and fx will be x cube minus 2. So if you apply the formula, limit as n tending to infinity, summation k equal to 1 to n, f of a is 1 plus k delta x is 3 by n, into delta x, 3 by n. This will be the Riemann sum. So that will be limit as n tending to infinity, summation k equal to 1 to n. It will be 1 plus 3k by n the whole cubed minus 2. That is your fx. Fx is x cube minus 2. So f of 1 plus 3k by n will be 1 plus 3k by n the whole cube minus 2 into 3 by n. So this would be the answer. Okay, now we move to the basic introduction of calculating area of a region. So to calculate area of a region, we divide the area into rectangles of equal width and then add the area. So when we do that, we have the left sum here. The left sum is given by integral a to b fx dx equal to f of x naught into delta x1 plus f of x1 into delta x2 plus f of xn minus 1 into delta xn. So we use the value of f at the left endpoint of each interval. That's why it is called the left sum, at the left endpoint of each interval. So that would also mean if you have the area here and we can actually divide it into, you have calculate the value here, then again calculate the value at this point, calculate the value at this point, and so on. So this is what we do. So this is the left sum. And similarly, we have the right sum. The right sum, you have integral a to b fx dx equal to f of x1 delta x1 plus f of x2 delta x2 plus f of xn delta xn, where we use the value of f at the right side of each subinterval. So we take the rightmost value. So that concludes the lesson for today. So we have learned how to calculate the Riemann sum using problems and also the basic introduction of the left sum and the right sum.